So I'm continuing the last session, that is we are discussing about the artificial neural network, and we have discussed this how the inputs are passed, and we know that each hidden layer consists of neurons and all inputs are connected to each neuron. And let us see how the computation performed in hidden layers are done in two steps. First of all the inputs are multiplied by their weights, and we know that the weight is the gradient or coefficient of each variable. It shows the strength of the particular input, and after assigning the weights, a bias variable is added. And remember that bias is a constant that helps the model to fit in the best possible way. So that the results is something we call it as a summation function. Generally we represent it with the help of a letter alphabet called as a Z. So Z equal to W1 into input 1, W2 into input 2. Likewise, we'll have how many number of inputs into its associated weights, and at last we are going to add a term called as the bias. And we know that these W2 are the weights, W1 to W5 are the weights assigned to the inputs, and these L1, L2 and so on is the inputs, and B is the bias. And then in the second step, this is the first step in the computation in hidden layer. In the second step, the activation function is applied to the linear equation Z1. Okay, just try to understand. Then we are in the hidden layer discussion. First step is we are going to calculate the Z1. In the second step, the activation function is applied to the linear equation Z1, and this activation function is a non-linear transformation that is applied to the input before sending it to the next layer of neurons. Okay, the importance of this activation function is to calculate the non-linearity in the model. So for every neural network, compulsory we have to apply the activation function. The output of the activation function itself is the predicted output. So the whole process described earlier is performed in each hidden layer, and after passing through every hidden layer, we move to the last layer, that is what we call it as the output layer, which gives us the final output. And the process explained above, okay, the process what I explained, Z equal to X, each input will have an associated weight, and we are going to multiply each input with the weight, and at last we are going to add a bias term, that is the summation function, and then later we are going to apply the activation function. So the whole this process, the process explained above, whole this is called as the forward propagation. Okay. After getting the predictions from the output layer, we are going to calculate the error. So what is the error? The difference between the actual value and the predicted value, that is we are going to calculate. And if the error is large, then the steps are taken to minimize the error, and for the same purpose what we use is the back propagation is performed. Okay, first we do the forward propagation, and the agenda is to calculate the error. If the error is more, we will back propagate to the input, starting from the changing of the weights to the activation function we'll call, and we'll try to minimize the error. That process generally we call it as the back propagation. See this particular diagram depicts what is the forward propagation and what is the backward propagation. I already explained the forward propagation. We are going to get the predicted output. The output what we got at last is the output layer, what is giving is the predicted output. Generally we represent it as the Y hat symbol, and then this predicted output we are going to compare with the actual output, and the actual minus predicted is called as the loss function, or simply we call it as also error. And that error we are going to find out the score for that, and we are going to apply some of the optimization algorithms to compute the gradients, where our agenda is to minimize the error, and then that leads to the updation of these weights. So here we'll start updation of these weights, and then we are going to apply the same Z function, then activation function, adding a bias term, and then we are going to get some output. Okay, if the error is minimized, we are going to stop the process. Otherwise, this is iterative process until loss function is minimized. So this is what is the process happening in a neural network: forward propagation and then the backward propagation. This picture clearly explains you what is the forward propagation and backward propagation, and remember that it is a iterative process until loss function is minimized. So what is this forward propagation? Already I told you, the process of computing the output of a neural network, that is multiplying inputs by weights, adding biases, and applying the activation function to produce the output. These three steps leads to the forward propagation. Then back propagation. The process of updating these weights and biases based on the error of the network predictions, and mainly it involves computing the gradient of the loss. Okay, this is the important thing. Computing the gradient of the loss function with respect to each weight using the chain rule. We are going to use a chain rule. Okay, with that we are going to find out the loss function. Then after that we are going to adjust the weights and biases to minimize the loss function. So this process is called as the back propagation. Okay, the same thing is the process of updating and finding the optimal values of weights or coefficient, which helps the model to minimize the error, that is the difference between the actual and the predicted values. Then how the weights are updated and new weights are calculated. So it is just with the help of optimizers. We have many optimizers. So with that we are going to update. So what are these optimizers? These are nothing but the methods or mathematical formulations to change the attributes of neural networks, that is weights, to minimize the error. And we have two important neural networks. One is single layer feed forward networks and multi-layer feed forward networks. So single layer feed network is the simplest form of a layered network. You can see this diagram represents the feed forward network with a single layer of neurons. So here there are only two layers. One is the input layer, other one is the output layer, which is the computation nodes. So it is feed forward, means the information flows from input to the output and not the vice versa. That's why we call it as only the feed forward network. And input layer of source nodes are not counted because no computation is performed. Only computation is performed at the output layer. So no input layer are counted. Then multi-layer feed forward network, you can see the difference of this particular diagram and this diagram. We have n number of hidden neurons. So when we have a hidden neurons, we can say that it is a multi-layer feed forward networks. So multi-layer feed forward networks has one or more hidden layers, and by adding this hidden layers, the network is enabled to extract higher order statistics from its inputs. And in this structure, the computation nodes are called as the hidden neurons or hidden units. Whereas in the earlier single layer feed forward network, the computation nodes are the output nodes itself. But here, as we have hidden neurons, these are the computation nodes. And this the example architecture what we have displayed here, generally we refer to it as 10-4-2 network. So what do you mean by the 10-4-2 is, we have a 10 source nodes are the input nodes and the four hidden neurons and the 2 output neurons. So that's why we call this network as 10-4-2. If a question comes like 8-6-2, then you should modify the diagram accordingly as per the this prescribed this form, not formula exactly. So we are going to network, we are going to define in this way. If it is 8-6-2, then you should have a 8 source nodes, 6 hidden layers with 2 output layers. So this is what we call it as the fully connected feed forward network with 1 hidden layer and 1 output layer. So this is what the difference between single layer feed forward network and the multi-layer feed forward network. Thank you.